Hi, this is Shoikat Majumdar. Our course code is BSPH101. It falls under the category Basic Science Courses. Course title is Physics 1. It is for the first semester students. Credit is 4. Prerequisite for this course is knowledge of 10 plus 2 physics. Course objective is basic concept of optics and its applications. We will discuss the interference of light. You have seen beautiful colors in soap films. How these colors are formed? These colors are formed due to the phenomenon of interference of light. As well as you can see this when some oil is fall on water or petrol is on petrol or diesel is on road, then you can see the patches of colors, beautiful colors in oils and on water films. The mechanism of these colors is due to the interference of light that is shown here in the presentation. Light is incidenting and it is reflecting back from different surfaces. They are maintaining the path difference. Under the condition of the path differences, they will produce constructive or destructive interference. Then the color in the fringes will form. Now, of interference of light. When two wave trains coming from coherent sources superimpose each other, produce alternate bright and dark bands. This phenomenon of light is known as interference of light. Now, what are the coherent sources? Actually, there is no existence of coherent sources. Coherent sources are the virtual sources. When two sources emitting light waves of same frequency, same or nearly same amplitude, and they must maintain a constant phase relationship, these sources are known as the coherent sources. Now, there are two independent coherences. One is temporal coherence, another one is spatial coherence. Now, here we are showing you the temporal coherence time and spatial coherence length. In temporal coherence time is a time the wavefronts remain equally spaced. It is evident from the picture. Wavefronts remain equally in space. That is, the field remains sinusoidal with the wavelength. In spatial coherence, the coherent length is the distance over which the beam wavefronts remains flat. This is how it is. Now we will discuss the next part, wavefront. A source of light spreads its disturbance in all directions in vacuum or in homogeneous medium. The points, those are situated at equal distance from the source of light, will vibrate in the same phase. Any moment, the continuous locus of each such point having same phase of vibration is called wavefront. Suppose you are dropping a stone in a pond, what will happen? The continuous crest and trough are produced and they will move towards the end of the pond. That means there is a wave there is a wave. Where we have dropped the stone, it is the primary source of disturbance. So from Huygens principle, each primary source of disturbance will produce the secondary sources of disturbance. This is, you can see, this is the primary source of disturbance, this is the secondary source of disturbance. Now, the wavefront is the envelope of the wavelets. So secondary source of disturbance will also produce the wavelets. If you envelop in a semicircular way, then, or semispherical way, then this is a wavefront. Here in our case, AB and CD are the two wavefronts. If the point source is this, these are all the secondary wave sources, secondary disturbances. Now we are enveloping these spherical wavelets. So this is the primary wavefront, this is the secondary wavefront. First one is the primary wavefront to the center, and this is the secondary wavefront. Now wavefronts may be of different types: spherical wavefronts, cylindrical wavefronts, plane wavefronts. Suppose you are just switched on a torch. Torch is giving you the light, and a cardboard is placed inside the just along the path of the torch. Then the light will fall on the cardboard. The light, that is the plane wavefront. Suppose tube light is glowing, this is a cylindrical wavefront. So a small bulb is glowing, this is a spherical wavefront, it is going in all directions. Now coherence time. Coherence is a coherence time. Time interval for which phase difference remains constant is called coherence time. Phase difference is depending upon the path difference. We know phase difference is equal to 2 pi by lambda into path difference, where lambda is the wavelength of light used. If c be the velocity of light, coherent length LC is equal to c into tau c. Tau c is the coherent time. Now coherent sources can be obtained by two methods. One is division of wavefront, another one is division of amplitude. In case of division of wavefront, narrow sources are required. In case of division of amplitude, broader sources are required. For Young's double slit experiment, we can see the division of wavefront, and for Newton's ring experiment, we can see the division of amplitude. Young's experiment, already we know from our class 12 syllabus, continuous crests and turfs are produced. When they are meeting in same phase, they will produce bright spots. When they are meeting in opposite phase, suppose crest turf, then it will produce dark spot. When crest, then bright spot. So this is how the interference patches